Welcome to Creative Peptides. Today, we talk about the application of peptide nucleic acids. PNAs are synthetic DNA analogues in which the phosphodiester backbone is replaced by repetitive units of N2-aminoethyl glycine to which the purine and pyrimidine bases are attached via a methylcarbonyl linker. The PNA molecules can routinely be labeled with biotin or various fluorophores. The unique chemical makeup provides PNA with unique hybridization characteristics. PNA molecules were first used in antigene and antisense assays. Several in vitro studies demonstrated the ability of PNAs to inhibit both eukaryotic translation and transcription. PNA-mediated inhibition of gene transcription is mainly due to the formation of strand-invaded complexes or strand displacement in DNA targets. PNA targeted against the promoter region of a gene can form stable PNA-D.N.A complexes that restrict the DNA access of the polymerase, whereas PNA complexes located far from the promoter can block the polymerase progression and lead to production of truncated RNA transcripts. One of the serious problems which is emerging at an alarming rate is the increasing multi-drug-resistant bacteria. These bacterial pathogens exhibit resistance towards conventional antibiotics due to excessive use of these antibiotics, and resistance genes transfer within the bacteria. Researchers desperately require new antibacterial drugs for the treatment of patients infected with drug-resistant bacteria. Antisense PNAs as antibacterial agents were found to treat infections caused by multi-drug-resistant bacteria. PRF1 signal is responsible for synthesizing RNA replicase polyproteins in virus for genome replication, especially for severe acute respiratory syndrome coronavirus replication. Li et al. Evaluated the potential antiviral effect of APNAs with RNA sequence on the PRF1 signal as target. In medical and biological research laboratories, polymerase chain reaction (PCR) is a frequent technique to amplify a DNA target sequence, generating thousands of copies for a variety of biomedical applications. PNA-mediated PCR clamping was also used for the amplification and consequently identification of minor allele in blood chimerism, whereas direct sequencing of ordinary PCR product could not identify it. Techniques like PNA FISH are used for the specific and selective identification of S. aureus. PNA FISH methodology was also used for the diagnosis of bacterial vaginosis, which is a common vaginal infection. The method was found to be time-saving, highly specific, and provided a valuable and trustful diagnostic tool. PNA FISH was found to be useful for the detection of pathogenic Mycetophanomyces invadans, which is responsible for ulcerative mycosis, a skin disease caused by a fungus-like agent of wild and cultured fish. In another study, PNA probe fish assay was used for detecting mycobacteria with great specificity and sensitivity, which helps in the fast and effective treatment of tuberculosis. During past few decades, biosensor technology has gained considerable attention in playing a significant analytical role in different industrial and academic applications, especially in certain areas like medical, environmental, food, quarantine control, safety, security, as well as defense. Singh et al. Reviewed the use of PNA-based biosensors that provide rapid, selective, sensitive, cost-effective, simple, and precise detection of DNA hybridization. These biosensors are quite functional in perceiving targeted genes which are responsible for particular disease. Colorimetric assay is another important method of DNA detection, which is based on the aggregation of unmodified metallic nanoparticles. In this hybridization-based method, charged neutral PNA were used as a coagulant of citrate anion-coated particles, and the assay was validated using gold, O, and silver, Ag, nanoparticles, NPs. It was found that for discriminating single base mismatch, the Ag NPs possess greater sensitivity than ONPs, further improving the accuracy of result with the use of the multiple aggregation signatures from the two types of nanoparticles. SPRging enhanced by ultrasensitive nanoparticles also uses PNA probes for detecting single nucleotide mismatches in DNA sequences with greater selectivity. If you need peptides and related services, please don't forget to contact us.